Hey everybody, this is Andy Malbuff, and this video is going to be a continuing look at feedback that we can put into Desmos Activity Builder for students using the computation layer. Specifically, we're going to see how we can add a little bit of animation to help build up and bolster some of that interpretive feedback that we want students to be able to make. Student feedback, just to review, can come in two different forms. Evaluative, which is like auto-generating it with computer programming skills, and interpretive feedback, where students get to actually see the results of what they submit and can make judgments themselves as to whether or not the responses are correct. So we're going to hopefully build upon the interpretive part of that here in just a moment. Now on this screen, this is the student screen preview. We might be asking our students, what's the slope of the line shown, and provide them with a graphed line already. So we're looking for the student to produce a slope of 3. Well, if they type in a 3, I can set up the computation layer so my teacher dashboard gets correct or incorrect feedback, but when the student presses submit, they get nothing. So if they get a correct response, they get nothing. If they press put in an incorrect response, they get nothing. If they put in some ridiculous answer, they get nothing. So we would at least want to have some evaluative feedback in there, which tells the students something about their response. So I'm going to exit preview mode here, and I'm going to go into the note in the on this particular slide. And I've already set this up in advance because I've already done videos with this and talked about it, and that's using a variable for feedback. So my feedback variable, I just use the word feedback, and then I give it conditions. And let's blow this up a little bit so it's a little bit easier to read. So here's the first condition. When input 1, which is how I identified or labeled the component where the students will submit their answer, when input 1 has a numeric value of 3 and is the key part, it's also been submitted, the student gets this particular message, which is nice, just a little bit of positive feedback. But if that condition is not met, Activity Builder goes down to this next one yet. If input 1 has been submitted, so that means the answer has not been inputted as 3, but rather something else is submitted, the student will get this piece of feedback. Well, in a way that's better than no feedback, that's not really very helpful to them at all in understanding the concept. And if the submit button has not been pressed, nothing gets shown here. Well, what we have to do is make sure that feedback shows up here. So I'm going to add it to my note. And let's preview. So here's the preview screen. If the student types in a correct slope and presses submit, they get this piece of feedback. If they type in an incorrect slope and press submit, they get this piece of feedback. Okay, and it's always auto-generated. So while again, this is better than nothing, this can be improved upon by giving the students something to interpret on the graph. So let me go ahead and exit this out, and we'll take a look at another example. I'm going to go to my second screen that I have set up here, and I'm going to jump right into preview mode. And here we're asking students to identify an ordered pair. Well, we can clearly see there's an x coordinate of 2 and a y coordinate of 6. So if the student inputs that and presses submit, nothing. They get no feedback whatsoever. So if this is being done from a remote setting, the student, they would have a hard time determining whether or not that is correct. So how do we build some interpretive feedback into this? Let me go ahead and exit the preview mode, actually, and jump back into preview mode because I want to show you what this could look like. So this is the third screen I have on this slide, and it's got the same information, but I've got some feedback put into this. So if the student types in a correct response, 2,6, watch what happens interpretively over here on the graph once they press submit. We've animated a point. And so the blue point represents the student's point. So they can instantly look at this and say, all right, I matched that. I've identified the point correctly. If the student types in an incorrect response, hopefully they can see visually, all right, my point is not where it should be. I need to make a correction. I need to make an adjustment. What is that adjustment? So this type of animation for interpretive feedback, I think is pretty cool for kids to see, and it's pretty engaging. How do we build that? Well, that happens in the editing part. So let me jump into, you'll see on this screen, I'm in edit mode. I've got my graph component, note component, and my math input component. And we're going to make some adjustments to this to put in some interpretive feedback. Here's the point. I'm seeing students that I want students to see. And then I want to have their response also go in here. So right now, we don't know what that response is. We're going to call it point AB with variables. Desmos can't graph this yet, and they'll ask you, what are A and B? A and B aren't defined. Well, watch what happens if I just simply put in sliders. Now, right away, I don't like having the same color. I'm very picky about that. I want students' responses to be offset and be a little bit different. Now this is a movable point. Watch what happens graphically. So it can move horizontally by A changing, vertically by B changing. But I don't want A and B to be defined here. I want A and B to be connected to what the student inputs. So I'm going to get rid of those. And this won't be able to be graphed yet until I define what A and B are in the computation layer. So I'm going to go into the computation layer, and because there's some typing involved, I have this set up already. It's just not active yet. What I want to do first is I want to make a variable that takes what the student input is and parses it. That's the mathematical lingo here. Parsing in ordered pairs, basically taking an ordered pair and separating it. So I'm calling my variable student point. And that variable is going to be equal to input 3, the LaTeX of input 3. Whatever the student inputs there is going to be parsed. The ordered pair is going to be parsed. It's going to be separated. So that's creating a variable, and we're calling that variable student point. Well, then, if you recall a few moments ago, we were in the graph component, and we wanted to graph A and B. Well, what I want to do is define A and B here. So here's how we will define A and B. I'm going to use a number sync. So we're going to define the number A as being the numeric value of student point.x. What this is doing is it's going to define A as being whatever the x part of this is going to be. That's basically what that's saying. We're going to define B as being the numeric value of the variable student point, the y part of it. So we're defining A and B here based on what the student input is. Okay, so we're going to leave this and go back and let's preview it. If the student were to type in 3, 4, for example, nothing happens. Okay, so what we've got to do is we've got to make some other adjustments here. So I'm going to jump back into here, and this says, okay, I don't know what A and B are, but we handled that already, didn't we? Well, let's jump back into the computation layer. Because I had copied this from a previous screen, and that's a frequent way to get computational layer to go into new slides, I had not changed the input. My input on this screen is titled input 2. So I'm going to change this. I just make that simple change. Nothing else here has to change yet. And let's see how that looks. I'm going to go into preview mode. I'm going to type in an ordered pair like 3, 4. And as soon as I hit the 4, the point gets graphed. And it's in the correct spot, but it gets graphed right away without the student checking or submitting the button. So I think that's a little fast. So here's where we use our timer concept that I really like to use. I'm going to add a timer to this. So to add the timer, so I'm going to go into my graph component, and I'm going to add a timer. What I'm going to do is take the X part of the student answer, and I want to multiply it by T. So I'm just going to hit times T, and I'm going to do the same with the Y part. And basically, that's going to invoke the timer to help animate this a little bit. So T is not recognized by Desmos. We have to define it in the computation layer. So I'm going to go in here, and I've already created this. Just like I used the number sync for A and B, I'm going to use the number sync for T as well. But rather than having the numeric value be assigned to an X or a Y, I want the component input 3. Oh, I better change that one too. I want that to be input 2 time sent submit. And what that's going to do is once input 2 has been submitted, it's going to start the timer T at 0, and it's going to run for 10 seconds. So let's see it in preview mode. If the student types in 3, 4, we should see some animation. Well, great. We do get the animation, but the point just keeps going and going and going. Okay, I don't want that to happen. That's because here, multiplying A by T, this just keeps blowing up bigger and bigger. So we have to set some conditions. So here's where I give a lot of credit. I was watching a Dan Meyer video, Desmos Live, and he was showing this. One of his colleagues did this, and I was so impressed with it. I'm like, all right, I'm going to push this out and share it with other people as well. We can add another concept in here to do this, and that's I'm going to define a new number. I'm just going to call it C because I've already used A and B. And I'm going to let C be the median between 0, comma, T, comma, and 1. Now, I don't want that to be actively graphed, so I'm just going to turn it off right here. But what's going to happen is C is going to be the middle number between starting at 0 and going up to a maximum of 1. And rather than multiply by T, I'm going to multiply these by C. So I'm going to replace that right there. So we're still being asked for sliders for A, B, and T. That's okay. They're defined in the computation layer. Let's see how this looks in preview mode. If we were to type in an ordered pair like 3, 4, there's the movement, and it stops when T gets to 1. So we've multiplied 3 by 1 and 4 by 1, and it stops right here where we want. So this is some really effective feedback, animated motion like this. If the student types in the correct response, look at that. That's great feedback. So this is just hopefully it's not a quick example, but an example of how you can spice up your interpretive feedback using animation and motion.